and here the geotextile act as a cushion for preventing the puncture of the geomembrane material. Here is also the geosynthetics material, this act as a drainage. This is the composite prefabricated this drainage media of a plastic core, that is such as mat or net, and the plate with the geotextile filter placed along the basement wall or the bridge abutment. Here this prefabricated drainage material act as a drainage function. Here this multi-layer of the horizontal drain in a saturated field. There are different layers of the geotextile material can be used as a drainage in saturated field. In case of the embankment construction, we can use the geotextile material at the base of the embankment, and here the geosynthetics material, this act as a drainage, and geosynthetic material has been placed between an embankment and the saturated, the soft soil. These are all the based on the drainage functional concept. There are some other this material which can also this act as a filtration. For an example, that in case of a vertical drain, here these are the band drain. It is a plastic core and wrapped with the geotextile material. Also we can sometimes use the natural material like jute and the coir, and can be used as a vertical drain for consolidation. Here this geosynthetics material act as a filter. A geosynthetics function as a filter when placed in contact with the soil, and it allow the water seeping from the soil pass through while preventing the most soil particle from being carried away by the water current. Now this is another area where the geosynthetic material also act as a filtration. This is the gravel filled trench drain and wrapped with the geotextile material. So it is very easy to install and construct this drain, and it is much more cheaper than the conventional method. There are some other this area where the geosynthetics material also act as a drainage. This is a perforated this pipe, and this also wrapped with the geotextile material. Here the geosynthetics material also act as a filtration. This is another example of the filter between the earth and this gabions. Here also geosynthetics material act as a drainage and the filtration. This is in case of rockfill dam. The geotextile material is placed here and it filtered between the two zones of a zoned earth rockfill dam. So geosynthetics material here also act as a filtration. This is also the another area for the construction of the embankment on a very soft or the soft soil, and here the geosynthetics material has been placed and this filter between the permeable this embankment and the saturated the soft soil undergoing that consolidation. Here the geosynthetics material act not only as a filtration but also as a separation, because the uniqueness of the geosynthetics material is that it has a multiply function. Now some of the other application of geosynthetics as a filtration. So here the geosynthetics material is shown in dotted line, and this filters between the earth bank and the rock protected or the rip wrap. Here geosynthetics material act as a filtration. This is another area. This is the geosynthetics material. It filter the preventing the erosion of bottom of the underwater excavation. So these are the some application of the geosynthetics as a filtration function. Geosynthetics material also act as a separation. So, here the geosynthetics material placed between a fine soil and the coarser material, it may be gravel, stone or the rock, it functions as a separator when it prevents the fine soil and the coarser material from mixing under the action of the applied load. Here a geotextile is placed between the railroad ballast and the foundation soil. Here geotextile material, its primary function is a separation, though it has a secondary function as a drainage. So, here the primary function as a separation. Now, here this geotextile is placed between the subgrade soil and this aggregate layer to form a parking lot or storage area or the working area. So, geosynthetics material act as a separation. Here also geotextile is placed between the two layers of the structure of a paved road. So, here the geosynthetics material, this act as a separation. In the geosynthetics material not only act as that 6 function, but there are some other function, that is the container. A geotextile function as a container when it contains the material such as sand, rock, fresh concrete. So, furnishing the placement of the this concrete, the geotextile function temporarily as a filter to allow the excess water to escape. Here the geotextile material, this act as a container, and a geotextile is to form a concrete mattress for the slope protection. Here the geotextile material have been used as a container. This is protection against this scouring. In case of the pile jacketing, there is a formation of neck. So we can rectify this necking by providing a geotextile material. So here this geotextile material, this act as a container. There are some other the application of geotextile material as a container. A geotextile is used to form a concrete at the base of an underwater foundation constructed over an uneven this bedding. This is the another this example where the geosynthetics material can be used as a container. This is the geotextile material used to form a concrete filled bag to plug a cavity in meaning or the in similar application. Geosynthetics material also can be used. A geotextile bridging a crack while supporting an unreinforced geomembrane is subjected to the pressure. So here this actually the geosynthetics material act as a tension membrane function. So a geotextile function as a tension membrane when it is placed between the two material having the different pressure. The geotextile assume a curved shape and its tension balance the pressure difference between the two material and thus strengthening the structure. Here is also this another example where the geosynthetics material this act as a tension membrane. This is the geotextile material, a geotextile used in a unpaved road preventing the heave of the soft subgrade soil between the wheel and providing the vertical upward reaction under this wheel. So here the geosynthetics material act as a tension membrane. Some of the this other application geosynthetic material application as a this functional concept, reinforcement functional concept, and here the geosynthetics material is placed and a embankment constructed when the geotextile is placed on a the soft soil Here the geosynthetics material act as a reinforcement. So a geotextile function as a reinforcement when it improves the mechanical behavior of a earth structure, but its tensile behavior when interacting with the soil through interface shear. There are this other example of the geosynthetics material where the geosynthetics material act as a reinforcement. In case of the construction of any steep slope, so this is the geosynthetics material has been placed in different layer, and we can construct a steep slope reinforce with several layers of the geotextile material. Here the geosynthetics material act as a reinforcement. In case of the construction of the vertical embankment or the reinforce with the several layer of the geotextile with this wrap around the facing. This is a geotextile material, and then soil is compacted and this wrapped with the geotextile material. So one can construct a retaining wall, geosynthetics retaining wall, and where the geosynthetics material act as a reinforcement function. Now this is the area where the geosynthetics material also act as a reinforcement. This is a multi-layer geotextile soil cover placed over a pipe or a culvert, a cavity or a sinkhole or a lens of very soft soil. Here the geosynthetics material is act as a reinforcement. Sometimes the geosynthetics this material also this act as a cushion, and in a cushion means a geotextile is placed between the two material. Its function as a cushion when it's elevate or disturb the stresses and strain, is transmitted to the material to be protected. Here a geotextile material is protecting the geomembrane from being punctured by the sharp stone protruding from the bedding and open this under a geomembrane. A geotextile also function as a drainage. So here the geotextile main function as a cushion and also the secondary function as the drainage. This is another area where we can use the geosynthetics material as this cushion. Here a geotextile is protecting a geomembrane from being punctured or abraded by the earth cover or the gravel drain. So these are the various application of the geosynthetics in civil engineering, and it is not only that geosynthetics material act as a separation, reinforcement, filtration, drainage, waterproofing or sealing, but also the some other function like the container, the tension membrane on the cushion, and also as a screen. So these are the major this application of the geosynthetics in a different project in civil engineering. Well, there are different application of the geosynthetics in different area. Some of them here, the geosynthetics material can be used in the road works, where it improve the subgrade of highway and the motorways. These airport runways, the parking apron, the car park, low traffic road, unpaved road, prevention and the treatment of the crack in pavement and the runway. The geosynthetics material can also be used in railway works, stabilization of the track decade, is protection of the embankment, the drainage of soldier and intermittent drainage. It has also the application in river works as erosion protection, then protection of bank of navigable waterways and cut-off walls. It can be used also in coastal works, protection of bank, shore defenses, that sea, dikes, also in creeks and hydraulic embankment. Geosynthetics material, this also can be used as the water works, is irrigation channel, earth dam, reservoir and multi-layer formation. There are some other this application as the drainage sewerage, that is drain pipe jacket, drain pipe underlayer, the tent drain, then vertical drain, then drain trench jacket. It can also can be used in protection of sealing membrane, that is film, sheets, or of hydraulic structure like dam and irrigation channel, and sealing system of building, or buried piping, gas and oil pipelines. It has also been used in the park, garden and the sports ground as a garden path, flower beds, roof garden, sports ground, track, race track, training track for the rehearsals. The geosynthetics material also can be used as a laying. The stripping and the leveling the ground, unrolling the sheet, addition of gravel as work proceed, spreading and leveling the road, making materials, compacting, and method of jointing sheets together as a superposition, stitching and stabling. There are some general earthwork. The geosynthetics can be also used as job site track and approach road, farm and forest track, improve the subgrade, the embankment of compressible soil, the storage areas, the factory deck and multilayer formation. This is title of this topic is geotextile testing. There are different types of geotextile testings, and those are the mechanical testing, hydraulic testing and physical testing. In the mechanical testing, there are puncture resistance, grab tensile test, steep tensile test, wide width tensile test, hydraulic brush test and the trapezoidal tear testing. In case of the hydraulic testing, there are apparent opening size or the equivalent opening size, then water permeability in the vertical direction as well as in the horizontal direction, and transmittivity in the in plane of geotextile and geomembrane and other related product. In case of the physical properties, those are the fabric weight, the fabric thickness, the ultraviolet stability, chemical resistance and the biological resistance. Now, some of the tests in geotextile testing can be correlated with the field problem and the laboratory simulation. Field problem and the laboratory simulation. In case of the brush test, this is the field problem. These are the aggregate, this is the fabrics, and this is the subgrade. This can be simulated to the laboratory simulation, this brush test. Here is the pressure. In case of the graph tensile test, this is the geotextile material, and these are the aggregate, and which can be simulated with the laboratory test. Here is also the drop con test, either when the aggregate is flat. So we can conduct this severe plunger test, which is called also quasi statics test, or when the stone have a angular, it dropped on the geotextile material, we can conduct in the laboratory the drop con method, or it is the dynamic impact. So these are the sum of the laboratory test related to the fabric surveyability and the separation function. Now let us consider the some of the typical tests in geotextile. And number one is the geotextile testing on the thickness. As you can see in the slides, this is the equipment for the determination of the geotextile thickness. Now the thickness is measured as the distance perpendicular to the fabric's plane between the upper and the lower surfaces of the geotextile, measured in a specified pressure. Now thickness is expressed in terms of the millimeter. When specifies in conjunction with the fabric weight, the thickness is proportional to the cushion ability of the fabric and the plane through the capacity of the fabric. Now in case of the mechanical testing, that is called the puncture resistance test. Now this test method is used to measure the index puncture resistance of geotextile, geomembrane and other related product. The test shows the absorption of the force when the geotextile absorb a concentrated load, that is the road, and the embankment construction during the capacity of the field, railroad tamping, riprap placement, or filling of trench and drainage. A test specimen is fixed without tension between the circular planes of a ring clamp attached may secure in tensile testing this machine. A force is exerted against the center of the unsupported position of the testing specimen by a solid steel rod attached to the load indicator until the rupture of the specimens occurs. The maximum force the recorded is the value of the puncture resistance of the specimen. This test is accomplished without the consideration of the soil. So, the result can be used only indirectly. From this test we can determine that deformation coefficient, the stress and the strain. Next slides shows the graph tensile test. Now this test method is to determine the tensile strength and the tensile elongation of a geotextile sample. It should be used only as a index test. The tensile test is done without the consideration of the influence of the soil, as the width of the test here, as the width of the tested sample increases, the tensile value increases, since the contact length between the individual fiber is much better of at greater sample width. A sample is subjected to tensile stress via the clamp that are narrower in width than the sample. The test results are dependent not only on the strength of the tested fabrics, but also on its stiffness. The rupture occurs immediately in front of one of the clamp and is not distributed over the entire width of the test samples. The grab elongation is measured in conjunction with the grab tensile testing. The elongation is calculated by a comparison between the initial length and the final length of the specimen at the breaking point. The next test is the wide width test. Now, these slides shows the wide width test, and this test method cover the measurement of the tensile properties of the geotextile using a wide width stiff specimen tensile method. Now, the basic distinction between this test method and the other method for measuring the tensile properties is the width of the specimen, and this width by contrast is greater than the length of the specimen. The same fabric or some fabrics used in geotextile application have a tendency to contrast, that is neck down under a force in the gauge length area. The determination of the wide width stiff force elongation properties of the geotextile provides the design parameter for reinforcement type application. For example, the design of the reinforced embankment over soft soil, the construction of the reinforced soil retaining wall, and the stability of reinforced soil structure. So, here in case of the tensile strength of geotextile testing, we can see that the very large overall this neck down occurs for the non-woven geotextile in case of the uniaxial tensile testing. From this test result, we can determine the different types of the stress strain curve of the geotextile material. In this transparent sheet, you can see that fabric tensile strain and the fabric tensile stress for the different types of the material. It may be multi-filament woven geotextile material or the needle punched non-woven geotextile material, heat bonded non-woven geotextile material, and this curve shows the monofilament woven geotextile material. So this figure shows the stress strain curve of the geotextile material. So from this curve we can determine some of the most important parameters, and those are can be measured the modulus value of the geotextile. Here you can see that this is the stress strain curve, and you can determine that what should be the initial tangent modulus of geotextile. We can also measure that offset tangent modulus of geotextile material. So this is the offset, this is the modulus, and also we can measure the second modulus at a desired strain. So this is one of the most important parameter in geotextile engineering. Now let us discuss on the hydraulic brush strength test. Now this test there are different types of hydraulic brush strength test. This is Mullen brush, this is the ball burst, and this is the severe burst. So this test now this test simulate situation where the geotextile is forced through saturated fine grained soil into the pores of coarse material.